Hello, it's Tavonnia here, and today we're going to learn about organic chemistry. So let's define organic chemistry. It is the study of carbon molecules. The terminology to name these molecules is called nomenclature. IUPAC stands for International Union on Pure and Applied Chemistry. This is the worldwide system used to name organic molecules. Now let's talk about functional groups. There are many functional groups. An aldehyde is a molecule with a double bond and an oxygen and a hydrogen on the side. A ketone is close to an aldehyde, but instead of the double bond oxygen connecting to a carbon and hydrogen, it's between an R, which also can be assumed to be a carbon. A carboxylic acid is an R double bond and a OH group. An ester is a R double bond and oxygen connected to a carbon. An anhydride is basically an oxygen or ether group surrounded by two ketones. An amide looks like an aldehyde, but instead of a hydrogen, there is a nitrogen. Also, it's good to note that a carbonyl is a C double bond O group. These are your primary organic chemistry 1 functional groups, and there's more to come. Now, alkanes are just CH bonds, and depending on the number, the name changes. 1 is methane, and the branch substituent is methyl. 2 is ethane, and the branch is ethyl. 3 is propane, and the branch name is propyl. 4 is butane, and the branch is butyl. 5 is pentane, and the branch is pentyl. 6 is hexane, and the branch is hexyl. 7 heptane, branch heptyl. 8 octane, branch octyl. 9 I call it nonane, and the branch is nonyl. 10 is decane, and the branch is decyl. 11 is undecane, and the branch is undecyl. 12 is dodecane, and the branch is docyl. Now, when naming an organic compound, we follow the IUPAC rules. First, we locate the functional groups. We find the longest carbon chain, and we number them. We look for branch groups, name them, and give them a position. And last, you combine the information to form a word. Now let's try to name this molecule. Try to draw this. We don't have any blatant functional groups. This just looks like a regular skeletal structure, you see. However, if you count the longest chain, you will see that there's 8 carbons. So we have an octane. Also, I see 3 methyl groups. 2 is at the front and 1 is at the end. We are going to account for the 2 carbons or the 2 methyls in the front because there's more of them. And then we will count the last one last. So 2 methyls is on carbon 2, and there's 1 methyl on carbon 7. So the IUPAC name is going to be 227 tri because there's 3 methyl octane. Now let's try to name this molecule. The longest chain is 7 carbons, so we're working with a potential heptane, but I see a ketone and I also see an alcohol group, so potential is right. The ketone has a higher priority than the alcohol, so we will call this heptanon and not heptanol. The alcohol is at 4, and that will be called an hydroxy. And there is a methyl at 5. Because a ketone will be a part of the name, the base name, I number that one last. So the name will be 4 hydroxy, 5 methyl, 2 heptanon. Last but not least, the longest chain of the carbon is 7. We have a potential heptane, but I see an alcohol group. The alcohol will be a part of the base name, so heptanol, and the OH is at 2, but we will name that last because it's a part of the base. And I see a methyl at 5, so 5 methyl, 2 heptanol. And also don't forget to put your dashes in your commas when you have plurals, and you dash it when you need to separate them. Thank you so much for watching my video. Like and subscribe. Follow me on Instagram, TikTok, and you know that my nature is purpose.